Okay, guys. So basically, what we're looking at is electrolysis part two of three. If you are studying GCSE and you're up this late, then I don't know what you're doing. But anyway, what we're doing is this is electrolysis part two of three. What we're looking at today is aqueous solutions with halide ions. Now, if you haven't seen part one, I suggest you go and watch that at some point. And if you have seen that, then what I would suggest also is you go and watch the other video, which is about ions, because they're very important to the topic of electrolysis. So, what we're saying here is this is the reactivity series: potassium, sodium, lithium, calcium, magnesium, aluminium, zinc, iron, tin, lead, copper, silver, and gold. So let's look at an example. Let's say we are looking at sodium chloride and it is no longer molten, it is now aqueous. What does that mean? That means it's in solution of water. So what we need to consider, unlike last time, is water. Ions are going to be sodium chloride, which is going to be split up into sodium ions plus chloride ions. And also, because it's aqueous, we must consider H2O, right? And this always gets split up into hydrogen ions plus hydroxide ions. What is one of the most important things to know in terms of electrolysis is where hydrogen fits in. And hydrogen is a non-metal and it's going to fit in here. So it's just above copper. And so what this means is that it is more reactive than copper, but less reactive than everything else. So lead is more reactive than hydrogen, calcium is more reactive than hydrogen, but copper is less reactive. So we've got H2O, which makes H plus plus OH minus. And then we're going to do exactly the same as in part one. We're going to look at the cathode, which is negative. And so what we got to think about is which one of these ions is going to go to the negative cathode. It has to be a positive ion because opposites attract. But the question is, which one will attract? Is it going to be sodium and is it going to be hydrogen? And here is the rule that you need to know. The least reactive cation will go to the cathode. And by the way, cation is the positively charged ion. So if you look at sodium and you look at hydrogen, which one is less reactive? Well, hydrogen is less reactive, so it is going to form at the cathode. So in this case, what's going to form at the cathode is going to be hydrogen, and that's all foundation people need to know. Hydrogen ions, which is going to be H plus, and it's going to make hydrogen because, as we said in part one of the video, it's going to be diatomic. So we need to balance this with the numbers of atoms, which is 2H. And now that we've balanced the atoms, we need to balance the charge. So we've got two positive charge here. The charge on the opposite side is 0. So we're going to balance this with 2 electrons. Fantastic. Then what we're going to do is going to look at the anode. Now the anode is positive, and so the only type of ions that can go to the anode is going to be the negative ions, right? And so we need a new rule here. And the rule is, what is the rule? The rule is if a halide ion is present, it will go to the anode. And is there a halide ion present? Yes, here's the chloride ion. So we're going to say Cl minus is going to make Cl2. Why Cl2? Because as you learned in part one of this series, Cl2 is diatomic when it's on its own. So now what we got to do is we got to balance the atoms. So we got 2 here, therefore I need to balance this with a 2. After you balance this with a 2, you're going to go with 2Cl minus here. There's 0 charge here, so we're going to put 2 negative electrons here. And there's one final thing that you need to consider, which is the solution at the end. Now, in terms of the solution at the end, you need to figure out what that is. How do you do that? You look at this. So you've got the cathode, and that's going to form hydrogen. The anode is going to form your chlorine. And therefore, what we can say here is we've used up the chloride ions, and we've used up as well the hydrogen ions. And so what we have left is we have Na plus and OH minus, which will make sodium hydroxide solution. And so basically this will have a pH of 14. Now let's do an example together. Let's go with MgF2. Let's do this together. So we're going to say it's aqueous. And what we're going to say is we're going to follow the exact steps. Okay, so we're going to look at the ions first. So let's do MgF2. So what's that going to split up into? Mg2 plus um, F minus, okay, -1. Now, of course, if you did want to balance it, of course, you'd put a 2 here and that would balance everything out, but I'm not that interested in that. I'm just looking at strictly the ions, okay? So it's F with a minus. Okay, now, what else must we consider? We need to consider water. Why? Because it's aqueous solution. And what does water always split up into? Hydrogen ions and hydroxide ions, right? That's what it splits up into. Again, we're going to look at the anode, which is, so it's positive, and which one of these ions are going to go to the anode. So if the anode is positive, it's only the negatives that could go to it. So it's either going to be the fluoride ions or the hydroxide ion. The rule is that if a halide ion is present, it will go to the anode. Is a halide ion present? Yes, it is. There it is. So it will go to the anode. So it's going to be F minus. Once it gets there, what's it going to form? It's going to form F2 because it's diatomic. F minus is going to go to the anode because it's negatively charged. It's going to form F2 because it's diatomic. We're going to balance the atoms now by putting a 2 here. And then we need to balance the charges by putting 2 electrons on this side. By the way, this is oxidation because we are losing electrons. Right, fantastic. Then we're going to look at the cathode. And in terms of the cathode, it is negative. So which one is going to go to the cathode? Well, this is negative, so it's going to be one of these two positive ions. Let's look at the rules. It says the least reactive cation will go to the cathode. So we've got magnesium and hydrogen. So magnesium is here, hydrogen is all the way over here. Which one is least reactive? It's the hydrogen. So hydrogen will form. So for foundation, all you need to say is hydrogen forms. Everybody else higher needs to be able to write this half equation. So the hydrogen ion will go towards the cathode because it's positively charged and it's going to form hydrogen, which is H2, diatomic. Then you balance it with the atoms and then you got to balance the charge. So we're going to add 2E minus here. And by the way, what is this type of process called? This is reduction because we are gaining electrons. Final solution, we need to know what the solution is. So the solution that is going to be formed in this instance, so let's cancel out what we used. So we used up the hydrogen, the fluoride ions, and we used up the hydrogen ions. So what we're going to have Mg2 plus remaining, plus the hydroxide ions, which is going to make Mg. And guys, I highly suggest you look at my ions video when you have time, because that explains how to do all of this, okay? So this is going to be MgOH2, which is a hydroxide solution. So we're going to look at lithium bromide, which is LiBr. And basically what we're going to do is we're going to split these up into its ions. So the first part is lithium bromide. If I split these up into its ions, we're going to get Li plus plus Br minus. And what else must we consider? Because it is aqueous, we must consider water. So it's going to get split up into hydrogen ions plus your hydroxide ions, right? And now we need to say, okay, well, the cathode is negatively charged. So now we need to figure out which one of these ions is going to go to the cathode. So the cathode itself is negative. So it's either going to be this lithium ion or the hydrogen ion because opposites attract. The least reactive will go to the cathode. It's going to be hydrogen ions. Hydrogen is going to form at the cathode. That's what foundation need to know. Higher need to be able to do the half equation. So it's H plus is going to form hydrogen, which is H2, and then you're going to balance those atoms and then balance the charge. And of course, this is reduction because we've got a gain of electrons. Now, and then we're going to look at the anode. So if you look at the anode, guys and girls, it is positively charged. And so we have only the negative, one of the negative ions can get to it. It's either going to be the bromide or the hydroxide ion. And the rule here is that if a halide is present, it will go to the anode. So we're going to say the halide is present. So it's going to be, what's going to form there? It's going to be bromine will form there for foundation, but for higher, you need to be able to write the half equation. So it's going to form bromine, and so we need to balance that with a 2. And then we need to balance the charge with 2e minus. And this, by the way, guys, is oxidation because we are losing electrons. And now we need to look at the solution. What is the solution? Again, all we do is we cancel out the ones that we've used, in this case, bromine and hydrogen. And then we're left with lithium and the hydroxide ion. So we're going to say lithium plus the hydroxide ions. And what does that make? It is LiOH. Good. It is LiOH. All right, guys, here is the last question. And then we are done with part 2 of 3. So let's go with copper chloride, CuCl2, right? And we're going to go with the ions. So we're going to split up the ions. And of course, we are talking about copper chloride aqueous. So that's really important that I state that. The ions, we're going to say CuCl2, and we're going to split it up into its ions. Cu2 plus Cl minus. Now, of course, like I said, if you do want to balance the charges and the atoms, you can do, but I'm not too interested in that. And what else must we consider? Because it's aqueous, we must consider water. What does water get split up into? Water gets split up into hydrogen ions plus hydroxide ions. And now we can start looking at our cathode and all that good stuff. So the cathode is negative. So we're either going to have copper ions going to it or hydrogen ions because opposites attract. The copper ions going. Why? Because the copper ions are less reactive in terms of when you're comparing the copper with the hydrogen ions. So we're going to have the copper ions going, and therefore foundation people need to know what's going to form at the cathode, copper. And so what we're going to have is the Cu. It's going to be monatomic because metals are monatomic. Now the atoms are balanced, and all we need to do is balance the charge. And so there's 2e minus, and this, of course, is reduction because we are gaining electrons. Then what we have at the anode is we're going to have either one of these negative ions going, so it's either going to be the chloride ions or the hydroxide ions. So which one is going to actually form at the anode? It's going to be the chlorine, because the halide ion is present. Okay, so you're gonna have Cl minus, and then it's gonna form Cl2. So we need to balance the atoms. There's gonna be a 2 here, and then we need to balance the charges. So we're gonna add 2e minus here. And this is oxidation because we are losing electrons. And finally, we need to look at the solution. So cancel out what we've used. We used the copper, we used up the copper, and we used up the chlorine. Yes, we did. And so what do we have? We have H plus OH minus. It makes H2O. So our pH would be 7. It would be neutral. Hydrogen is not at the cathode. Why? Because copper is less reactive than hydrogen. Guys, if you're new here, make sure you're following.